good morning.
Good morning, sir.
It's great to be here this morning with you. And, I just got to tell you, it was a great presentation, I think you'll all agree, from General Hyten. And just to kind of frame it for you a little bit, so I work for General Hyten in a couple of capacities. I am his Army Service Component Command for U.S. STRATCOM, so we provide the global missile defense as well as the space component, Army space component to U.S. STRATCOM. That's one area that I work with for General Hyten. The second one is for the Joint Force Component Command for Integrated Missile Defense. So really, for me, it's an honor or privilege to work for General Hyten on a daily basis. And today I'm going to talk a little bit about, or actually a lot about, the command that supports General Hyten. He talked about the 162,000 folks that stand watch around the world and performing the missions for STRATCOM. I'm going to give you a sliver of that from the Army Space and Global Missile Defense component, which is about 3,000 strong. So I will show you today, my intent is to kind of show you how powerful those individuals are, and I'm going to let them tell the story for you rather than me doing all the talking. So I've got a lot to cover this morning, and so what we'll do, let's go ahead and roll the video. All right, what'd you think? All right, good, all right. I learned a long time ago you always need a HUA video to start out. And with a tough act to follow like General Hyten, my boss, I got to pump you up this morning and get you started on our portion of this briefing. So what I'm going to do, you know, after being in command for about a year and a half now, you know, like every command I've had up to this point, you really know that the strength of your command lies within the folks that work for you, the folks that pull that watch 24/7, 365 around the world. And really, this morning, I'm going to try to show you that as we talk to the soldiers, the sailors, the airmen, and the Marines, and the civilians of a team of just about 3,000 folks. And you think to yourself, 3,000, that's not a large workforce, that's not a large force in itself. But what you're going to find out as I go through my remarks this morning is that they're a team of highly skilled individuals. They are a multi-component team, meaning that they belong to the active service, active Army, United States Army Reserve, and the Army National Guard. You'll also find that we have a good joint team, a great joint team in the JFCCIMD, and you'll also find that we've got allied and partners that are working with us, both in SMDC ARSTRAT as well as JFCCIMD. You'll also find as we go through this, you'll find that we are a globally dispersed command. So we span across 11 different time zones and 23 different locations around the world. So this morning what I'm going to do is I'm going to introduce these service members to you and civilians who contribute to the Army and the Joint Force Space and Missile Defense Enterprises, both enterprises. In a series of short videos and live question and answer, they'll describe their mission areas and how they contribute to the Joint Force. We will look at how the command develops concepts and technologies, trains the forces, innovates and experiments, and accomplishes the wide-ranging space and global missile defense missions for the nation today. So this morning, to begin with, I'm going to introduce you to the Space and Missile Defense's Future Warfare Center, which is the Army Forces modernization proponent responsible for managing Army change to doctrine, organization, training, material, leadership, education, personnel, facilities, and policy, or DOTMIL-PF, requirements for space, global ballistic missile defense, and high-altitude capabilities.
I'm Brent Frazier, and I'm the Acting Deputy Director for the Capability Development Integration Directorate for the Space and Missile Defense Command and Chief of Concepts. Thanks for the opportunity to speak with you all today. I'm stationed at the Joint Base Langley-Eustis in Virginia with teams from Colorado Springs, Redstone Arsenal, as well as across most of the Army's centers of excellence. Our team's core competencies include the assessing, development, and integration of concepts on space, global ballistic missile defense, and high altitude, organizational design and force structure reviews, as well as cultivating learning from the Army's campaign of learning. Concepts describe how we think about future warfare. They establish a sound foundational basis for future force development. Concept to capability development is aligned with Army priorities, acquisition reform initiatives, and strategic guidance. Our work takes into account many foundational concepts, such as the Army operating concept, multi-domain operations, the echelons above brigade concept, as well as the Army functional concepts. In addition to these foundational concepts, we also address and assess the current and emerging and future operating environment, as well as advances in technology. Concept development work generally defines the problem statement, identifies key roles and responsibilities, identifies required capabilities, and broad components of the solution. SMDC concepts focus on space, high altitude, and ground-based mid-course defense, as well as Joint Tactical Army Ground Station and various supporting concepts, such as navigational warfare, position navigation and timing, and contributions to the multi-domain task force in multi-domain operations, as well as various joint capability areas, such as force application and battle space awareness. Thank you for the opportunity to talk with you this morning, and I look forward to further discussion and questions.
So joining us this morning is Brent Frazier from Fort Eustis, Virginia. Brent, there's been a lot of discussion lately about the multi-domain battle, the multi-domain operations. Tell us a little bit more why that's important to the Army.
Sir, multi-domain battle 1.0 is transitioning into a multi-domain operations 1.5. As General Townsend indicated as early as back in May, the Army is beginning to use the term multi-domain operations, or MDO, recognizing that battle is really just one part of joint operations. The current and future concepts mentioned in the video earlier and later this morning are needed after more than 15 years of focusing on counterinsurgency and counterterrorism, negatively trending budgets, and the emerging operational environment where our competitors are making some rapid technological advances and progress. The concepts provide the framework, and they really help prepare us for future warfare through wargaming, experimentation, exercises, and they help us facilitate learning while also help us focusing in on our scarce resources on the Army's highest priorities.
Brent, thank you, and really just to set the record straight, Brent's one of our very talented leaders within our organization. Brent is a career air defender. Thanks for that, those comments, and thanks for your service to our nation, Brent. Thank you. The Future Warfare Center is our architect for future design. It drives change to the current force focused on combat-ready forces and capabilities while integrating innovative solutions that are enabled by leap-ahead concepts and technologies. Our team that develops those leap-ahead technologies resides in the SMDC ARSTRAT Technical Center. The Tech Center provides critical technologies to achieving warfighting dominance. It manages our science and technology research, development, test, and evaluation efforts. And as part of the Army Science and Technology Enterprise, the Tech Center contributes to today's fight while enabling the next generation of warfighters. Its primary focus areas are directed energy, tactical space technologies, and cyberspace. The Technical Center is the Army's lead for high-energy laser development. This technology can be developed to address operational capability gaps in a variety of mission areas. High-energy lasers have the potential to be low-cost, effective complement to kinetic energy, addressing counter-rocket artillery and mortar threats, unmanned aerial systems, and cruise missiles. The Tech Center is also exploring the use of high-power microwave and systems in interdicting unmanned aerial systems and defeating improvised explosive devices and other improvised threats.
Thank you. I'm Adam Aberle with the Space and Missile Defense Command, Army Forces Strategic Command Technical Center, and our High Energy Laser Division. And I oversee our high energy laser technology development and demonstration activities. Behind me, you'll see the High Energy Laser Mobile Test Truck. We recently upgraded it to a 50 kilowatt class laser and are currently undergoing system checkout to verify performance before we take data and collect information on how a laser system will affect rockets, artillery, mortars, and UAS systems while in flight.
A demonstration on dynamic targets is being conducted at White Sands Missile Range as we speak. The data from this demonstration will be used to anchor models and simulations used in future high-energy tactical vehicle development. These and other efforts show some of the very exciting things the Directed Energy Division is working towards to support the future of U.S. warfighting operations. Ms. Fabiola Lopez is joining us from White Sands Missile Range today. Ms. Lopez is an engineer who oversees all the test activities at SMDC's solid-state laser testbed facility at White Sands Missile Range in New Mexico. Good morning, Ms. Lopez. These are, in fact, as we can tell, very complicated systems. How difficult is it to operate one?
Good morning, sir. This is a science and technology effort with engineers designing, developing, and operating our systems. However, we are working towards making them easily operated by the warfighters with as many automated systems checks as possible so that the warfighters can concentrate on the mission. In fact, over the last 2 years, we have had soldiers operating the MEHAL at several events. The first 2 were exercises at Fort Sill, and most recently, soldiers from the 2nd Cavalry Regiment operated the MEHAL during a limited live-fire exercises at the Joint Warfighting Assessment in Europe this past spring.
Well, thank you, Ms. Lopez, and good luck on the testing that's going to happen over the next month or so. Moving from ground-based defense technologies, next I'd like to highlight a technical center effort in tactical space technologies. As the Army's lead for space research, development, and engineering, the Technical Center identifies, develops, demonstrates, and integrates responsive space and space dominance technologies. A current focus area is persistent beyond the line of sight communications via small satellites for forces deployed in remote areas. We are addressing this need through the development of our own microsatellite called Kestrel-I. Our Kestrel-I effort includes functionally effective resolution imagery via small satellites, ground command and control systems to reduce operator burden, and direct downlink of tactical data feeds. Our lead engineer for Kestrel-I is Mr. John London.
General Dickinson and distinguished guests, my name is John London. I am the Chief Engineer for the Space and Strategic Systems Directorate here at SMDC. I want to talk to you today about a program called Kestrel-I. Kestrel-I is an imaging satellite that the Army here at SMDC has developed. It is the first imaging satellite that the Army has ever developed. It was launched in August of 2017 and is orbiting the Earth today. Behind me is one of two Kestrel-I ground stations. This particular ground station was developed in-house by a government team here at SMDC. We are partnered with the Office of the Secretary of Defense and also U.S. Indo-Pacific Command in executing this program. We have another ground station over at U.S. Indo-Pacific Command in Hawaii. This ground station, along with the one in Hawaii, are the two ground stations that we use to operate the satellite. The system was designed to operate in a fashion that allows the soldier to be able to task the satellite directly and receive the imagery directly from the satellite within minutes. This is an unprecedented capability, and it gives the soldier in the field enhanced combat power.
And this morning, we're being joined by Mr. London all the way from Redstone Arsenal. As you can see with the patch back behind us. So we're demonstrating our technical capability within the command. John, good morning, and would you tell us a little bit more about your team?
Sir, good morning. Kestrel-I is being operated by a team of government, civilians, contractors, and soldiers at the ground sites in Huntsville and in Hawaii. The Walt antenna was designed and built completely in-house by SMDC government civilians. The Kestrel-I team was able to witness the launch of their satellite from the Kennedy Space Center on a Falcon 9 rocket 1 year ago. SMDC's 1st Space Brigade has functioned as part of the Kestrel-I team, operating the satellite from the SMDC Payload Development Lab here in Huntsville. At this moment, Kestrel-I is in low Earth orbit, making its way across South America.
John, thank you very much for that and that long-distance call from Redstone Arsenal. But I will tell you also that what's impressive with that, if you remember the video with Mr. London in it, he had the antenna sitting back behind him. That antenna, along with many other components, were also partnered with our interns, engineering students that we have within the command. So very impressive to have such a young team working with a more experienced team. Notice I didn't say old, but experienced team that is developing our future workforce as we look to these new technologies. So John, thank you very much this morning. Another division within our technical center is the Ronald Reagan Ballistic Missile Defense Test Site, or RTS. RTS is a vital national asset providing live-fire, developmental, and operational flight testing of offensive and defensive missile systems, equatorial satellite launch capability, space object tracking and characterization, and atmospheric science research. The unique range and test facility is located 2,300 miles west-southwest of Hawaii, and the U.S. Army Garrison Kwajalein Atoll, Republic of the Marshall Islands. And that just sounds plain remote when you say 2,300 miles southwest of Hawaii.
Good morning, sir. Ladies and gentlemen, my name is Captain Wojciech Stachura. I am a U.S. Army space officer currently serving as the Deputy Chief for Space Operations Division. Today, I am here at the Kwajalein Atoll, home of the Ronald Reagan Ballistic Missile Defense Test Site, also known as RTS. The U.S. Army Garrison Kwajalein Atoll is located in the Republic of Marshall Islands in the Central Pacific. RTS is operated by a team of Army personnel, government civilians, technical support contractors, and scientists from MIT Lincoln Laboratories. We have over 40 years of experience supporting missile testing and space operations. RTS conducts continuous operations in support of the U.S. Strategic Command, U.S. Air Force space programs, and the National Aeronautics and Space Administration, as well as other government and DoD organizations. Operations on Kwajalein Atoll offer many advantages. The austere location helps minimize the inherent risk and safety concerns involved with launch operations, and its proximity to the equator and vast ocean areas make it very efficient at conducting rocket launches to a wide range of orbits. The Reagan test site is, and will continue to be, a significant asset for the U.S. Army.
And this morning we are joined by Captain Stashchura, one of our Army's FA-40 or Space Operations officers, all the way from Kwajalein Atoll. And I believe, if I'm doing the math correctly, it's very early morning tomorrow for him out there. I believe it's about 0200 or 0300. So again, highlighting the distances between our command or with the command operates in. So good morning, thanks for getting up early, and tell us a little bit about how the isolation of Kwajalein affects the mission out there.
Good morning, sir. Yes, it is almost 3 a.m. here. We have implemented many plans over the past 40 years to overcome the obstacles associated with being located in the middle of the Pacific. We have an incredibly high success rate with our missions. We are able to synchronize with our command headquarters in Huntsville and sustain all personnel and families living on the Kwajalein Atoll.
Captain Stashchura, I appreciate you getting up so early in the morning. Hopefully you have a good day. That backdrop that you had on your video, I think we were all a little envious of that, looking at the blue water, and I do believe the temperature of that water is probably about 80 degrees. So we'll leave you to your duty today, but thanks for joining us today. So we've heard from team members in concepts and development, science and technology, and our unique test facilities at RTS are all fundamental parts of developing space and missile defense capabilities and forces. Another essential aspect is training the force. The Army Space and Missile Defense School and Doctrine Center executes the Army's institutional training and education for space and global ballistic missile defense mission areas. The School and Doctrine Center coordinates and publishes the Army's doctrine for space and global missile defense. Mr. Darrell Breibach is the director of the Space and Missile Defense School.
Hello, General Dickinson. Ladies and gentlemen, I'm Darrell Breibach, director of the United States Army's Space and Missile Defense School located in Colorado Springs. As an element of SMDC, my organization is responsible for the following. We develop and execute training and education for space cadre members across the Army, as well as the operational forces within SMDC's 1st Space Brigade and 100th Missile Defense Brigade, which you'll hear from shortly. We integrate space and missile defense education and training venues across the entire Army training enterprise, and finally, we develop the Army's Space and Missile Defense Doctrine. But well before the first soldier is trained on a new capability, the school and training community begin working in close coordination with the capability developer as they prepare to bring a new or enhanced capability or piece of equipment to the operational force. Early in that capability development process, we define and document the who, what, where, when, and how for training of a new or improved capability. This helps ensure that the Army is programmed for the needed training resources and helps ensure that the school has the right facilities, training devices, and instructors in place to begin training once that first operational capability is delivered, while also ensuring that our training processes and materials are prepared according to Army and Army Training and Doctrine Command standards. But while operator training is critical to the success of a new or emerging operational capability, Army leaders and their staff at all levels must also receive instruction and education on a new capability. They need to understand how it supports the Army or Joint Warfighter and how to plan for as well as integrate the capability into plans and operations. This leader development typically takes place as part of the Army's professional military education or as part of unit-level training and exercises. And of course, SMDC plays an important role across the Army in this leader education. And finally, the new capability and methods of employment must be captured and written into doctrine. This can result in integration to existing Army joint or service doctrine, or when needed can result in the development of entirely new doctrine. Of course, doctrine is what guides the Army's use of a capability in support of operations, as well as delineates the tactics, techniques, and procedures for operating current capabilities in the current force, and can address capabilities expected to be delivered in the near future. Of course, training and doctrine development efforts begin early in the technology development and capability development process, and then continue across the entire life cycle of an Army piece of equipment or capability. So as you heard, soldier and leader training and doctrine are critical aspects of the Army's need for and reliance on space and missile defense capabilities.
This morning, we're joined by Daryl out in Colorado Springs, Colorado. It looks like he's sitting in one of our training labs for our students. Daryl, on an annual basis, how many students are educated through the facility that you're in charge of?
Yes, good morning from the school, sir. On an annual basis, we see about 3,000 soldiers trained and educated as part of our space and missile defense courses. We also reach out across the Army and partner with other schools by integrating space and missile defense education into curriculum at schools across the entire Army.
Daryl, I'm kind of looking there in the picture there. It looks like you got something going on up behind you. Can you tell us a little bit about
that? Yes, sir. As you mentioned, sir, we're sitting in one of our student labs. This is a spectrum lab where we give students hands-on opportunity to learn and understand the signals characterization and characterization environment.
Very good, very good. And what I want to point out too is while Daryl is sitting there with a coat and tie on today, Daryl is also a 23-year veteran in the United States Army Reserves, and he serves as a lieutenant colonel as an FA-40, or a space operations officer. So Daryl, thanks for your service, both wearing the coat and tie as well as wearing the uniform. Daryl and his team play a critical role in educating and training our forces, who in turn educate the Army on how space and missile defense can make them more lethal in combat and more effective in operational environments. Their input is essential to another of our capability development responsibilities, which is transitioning new technologies and innovations to the warfighter. This requires a lot of experimentation, prototyping, and warfighter feedback. That's another area that our Future Warfare Center covers.
Hi everyone, I'm Lieutenant Colonel Brett Bateman, Branch Chief for Trade-Out Capabilities Manager, Space, High Altitude, Experimentation, and Prototyping, which is a branch of the Capabilities Development Integration Directorate under the Future Warfare Center. Together with partners in DoD, industry, and academia, my branch researches, develops, integrates, and experiments with space and high-altitude prototype capabilities, innovating agile solutions to meet current and emerging warfighter needs. When complete, we transition those capabilities as required to DoD programs of record or industry. Our involvement complements other science and technology efforts as we assess the readiness of key technology to pace the threat in an operationally relevant environment. We lead the command's participation in joint, coalition, and Army's service-specific experimentation for a given doctrinal area, such as space and high altitude. We seek to effectively transition technology to the warfighter. How do we do it? Our methodology integrates academia and industry input with integration of Army systems engineering and architectures to meet the Army's operational environmental requirements. From this, we develop prototypes that are iteratively revised after warfighter touch time through experimentation venues that are typically provided by TRADOC Centers of Excellence. We then determine if sufficient military utility is present for handoff to a DD program of record, Industry Independent Research and Development, IRAD, or niche use directly by warfighters. One example of our current efforts to support the Army's modernization priorities is the Army Assured Rapid Detection, Validation, Asymmetrical Resilient Kinetic, Position Navigation and Timing, AARDVARC P&T, a GPS assurance prototype. This end-to-end system provides a mounted warfighter with real-time information in support of precision fires in a contemporary, near-peer threat environment by allowing the unit in the field to passively determine the quality of the P&T signal in their area of operation.
And this morning we're joined by Lieutenant Colonel Brett Bateman. Seems like the same seat that Daryl was in a few minutes ago. Lieutenant Colonel Bateman, what are some of the keys to keeping prototyping and experimentation processes lean and most importantly responsive to the warfighter's needs?
Sir, it's key to keep a focus on how a soldier would use this system in order to filter out system features that increase development time, cost, and especially time to produce a valid requirements document. We also closely monitor other DoD initiatives and commercial industries so we can not duplicate or compete against those other efforts, since in some instances they may provide the best solution for our requirements. We also need to be good listeners and collaborators with both industry and joint services.
So Brett, thank you. Brett is one of our acquisition experts that reside within the command, of which is a critical function for us, as you can tell, as we do rapid prototyping and system fielding and experimentation. So Brent, thank you for that this morning. Communications is the key for combat effectiveness and lethality in today's operational environment, and one of our unique functions is to provide assured space capabilities. Our regional satellite communications support centers provide premier SATCOM planning, engineering, and satellite payload management for SATCOM systems. They ensure SATCOM use based upon operational priority for all services in the Defense Information Systems Agency. Sergeant First Class Loren Warner does this important work for us every day.
Good afternoon, General Dickinson, ladies and gentlemen. I'm Sergeant First Class Loren Warner, assigned to the Regional SATCOM Support Center Pacific as a wideband planner. The ARSTRAT PAC provides all satellite communications, planning, engineering, and management in support of the combatant commander of U.S. Indo-Pacific Command. Our mission is to plan and engineer all SATCOM requirements for all services and international partners in the Indo-Pacific theater on a daily basis. This includes training and operational requirements in an area that covers over half of the Earth's surface. This support extends strategic and tactical communications networks in support of joint land, sea, and airborne forces. I've supported and participated in countless exercises in the Pacific, including Rim of the Pacific, Ulchi Freedom Guardian, and operational flight tests. My participation in these exercises and tests have given me a thorough understanding of what can be achieved by the joint force when we perform our mission. My time in the United States Army Space and Missile Defense Command has given me a new perspective on the importance of strategic communications and how we support the warfighter and control the high ground.
Sergeant First Class Warner is joining us from a very desirable place today, Hawaii. So Sergeant Warner, good to have you this morning. What is the most rewarding aspect, if you can tell us, about working at the RSSC Pacific?
Good morning, sir. The most rewarding aspect of working at the RSSC is knowing that the missions I plan positively affect the daily lives of all deployed service members in the Indo-Pacific theater by helping them perform their mission and maintain contact with their loved ones back home at the same time.
Very good, Sergeant First Class Warner. Thank you for that. He is a 19-year veteran of the Signal Corps and currently serving in one of the Signal communities or enterprises most coveted MOSs. He's what we call a 25 Sierra 1 Charlie, which are those soldiers that are doing just what he's talking about. We'll talk about talk to a few more of them later, but that is a very, very small part of the Signal branch, but a very, very important one. Thank you, Sergeant Warner. While we are speaking with our sites in the Pacific, let's also hear from our Wideband Satellite Operations Center there, which is one of 5 centers providing critical global and space support, and something that the Army only does.
Good morning, sir. I'm First Sergeant Shannon Sanchez. Today I have with me 2 of my operators, Staff Sergeant William Moy and Leading Seaman Rebecca Tuckwell.
Good morning, sir, ladies and gentlemen. My name is Staff Sergeant William Moy, active duty, U.S. Army. I'm a squad leader with Delta Company Defenders, 53rd Signal Battalion.
Sir, ladies and gentlemen, my name is Leading Seaman Rebecca Tuckwell of the Royal Australian Navy. I am also a member of Delta Company.
Sir, the Wideband Satellite Communications Operations Center, or WSOC, responsibilities include transmissions control, payload control, and platform control on a 24/7, 365 basis. The WSOC plays a significant role in defensive space control. We are continually fighting SATCOM. We are the first line of defense for assigned satellites, terminals, and users, and provide assured access to DoD-owned wideband satellite communications for U.S. DoD, OGA, and coalition partners.
Sir, the WSOC directly supports all branches of the US DoD, other US government agencies, and 8 partner nations. Those partner nations being Australia, Canada, Denmark, Luxembourg, Netherlands, the Czech Republic, Norway, and New Zealand. I am one of 10 Australian Defence Force cooperative project personnel assigned to Delta Company. In total, there are 15 Australian Defence Force members from all 3 services fully integrated throughout SMDC. This is a part of the WGS Memorandum of Understanding between Australia and the United States of America.
Well, this morning you can see we're joined live by those great individuals that just spoke to us, to include their first sergeant. So that's a great partnership that we've forged and continue to maintain. Leading Seaman Tuckwell, what do you enjoy most about working in a coalition environment?
Sir, what I enjoy most about working as a satellite controller is being able to directly influence real-time worldwide operations in support of allied operations around the globe.
Sergeant Moy, one final question. Who do you mainly support?
Sir, we're situated in the Indo-PACOM AOR, so our heaviest users are the Navy. However, when the phone rings, it could be a special user, a U.S. Army training mission, or an international partner that we're supporting.
Very good. Thank you, Leading Seaman Tuckwell and Staff Sergeant Moy. First Sergeant Sanchez, thank you also. First Sergeant Sanchez is really a product of the 1st Space Brigade. She actually started out with the brigade in the 1st Space Battalion, which is responsible for ARSTs and JTAGs, and now we've moved her over into the Signal Battalion in a key NCO leadership role. And so the expertise that she developed in the 1st Space Battalion is now migrated into the Signal Battalion, which is very important with the mission sets that they support. So to all of you there in beautiful Hawaii, thank you for joining us today. A critical factor in keeping our overseas forces safe is the ability to provide early warning from ballistic missile attack. The Joint Tactical Ground Stations, or JTAGs, provide this timely and potential life-saving capability.
Good morning, sir, and distinguished guests. I'm Captain Dustin Monlock, Commander of Alpha Detachment, 1st Space Company. Today I have Staff Sergeant Nicholas Masato, a certified JTAGS crew chief with over 3,000 operational hours at 2 separate detachments, CENTCOM and EUCOM.
Good morning, sir, and distinguished guests. I'm Staff Sergeant Nicholas Masato, an Engagement Control Team Leader in 1st Space Company. I am responsible for providing continuous theater ballistic missile early warning and queuing through the use of the Defense Support Program satellite constellation to the European, Central, and Indo-Pacific combatant commands. Here at JTAGS Europe, we receive and process in-theater direct downlink data from overhead persistent infrared sensors in order to disseminate warning, alerting, and queuing information on ballistic missiles and other events of interest throughout the theater. We run operations out of independent forward locations in EUCOM, CENTCOM, and Indo-Pacific combatant commands, providing 24-hour theater missile warning for commanders worldwide. Every JTAGS operator, regardless of rank, must progress through rigorous multi-level certification process and spend a specific amount of time on live mission in each position.
And this morning we have Staff Sergeant Masato and Captain Modlock from Germany. Captain Modlock, with JTAGS celebrating its 21st anniversary in operations, how have you seen the JTAGS operators training, improve, and adapt over the years?
Good morning, sir. So JTAGS operators go through rigorous initial qualification training in Colorado Springs, Colorado. The Army soldiers, contractors, and DA civilians that instruct at the state-of-the-art facility consistently take feedback from us at the forward detachments and frame training to be more relevant and set operators up for success in their profession. I'll now hand it over to Staff Sergeant Masato, who will provide a background of the new facility.
Good morning, sir. The facility is named after the late Dr. Peter G. Pappas, who is considered the father of JTAGS. He envisioned, demonstrated, and led the development of real-time processing of theater ballistic missile early warning data. Dr. Pappas' legacy lives on today with the continued development of early missile warning capabilities at the Space and Missile Defense School's Dr. Peter G. Pappas Training Facility.
All right, well, thank you very much for that, and that was a key milestone for the Army when we celebrated, or we're celebrating the 21st anniversary of Dr. Pappas. That was a result of Desert Storm and how we needed to get ballistic missile warning quickly down to the warfighter, and that capability still does that today, and of course over the years we've improved it quite a bit. So gentlemen, thank you for your time today. The U.S. Army is the largest military user of space, and today every service member is space enabled. We see, shoot, move, and communicate via satellites and space-enhanced assets. Our national security and defense strategies stress the vital importance of space, as well as how it is becoming increasingly contested. We support the warfighter's increasing use of space capabilities with our own Army space support teams.
I'm Major Wilkins with the Army Space Support Team 27 from the 117th Space Battalion of the Colorado Army National Guard, the only space unit in the Army National Guard. With me is Sergeant Faith, my satellite communications NCO. ARSTRAT deploy globally to support warfighters by executing the planning, coordination, integration, and synchronization of space support to operations.
ARSTRAT integrate with their supported unit commands and staffs to help characterize the operational environment, provide space input to intelligence preparation of the battlefield, and inject SMDC ARSTRAT emerging capabilities into the fight. The ARST is comprised of a 6-soldier cross-functional team with 2 space officers, an intelligence analyst NCO, a geospatial engineer NCO, and 2 signal soldiers.
Examples of areas where the ARST can deliver and integrate expertise are positioning, navigation, and timing effects on friendly and enemy forces, military and commercial SATCOM support, and planning for friendly forces to include solar weather mitigation, space-based intelligence, surveillance, and reconnaissance support, and overhead persistent infrared detection and notification of enemy force locations, and theater ballistic missile launches.
And this morning we're joined by Major Wilkins from the Middle East. And I just got to say before you start, in that video, you looked awfully cool. I wonder when you really recorded that. You weren't sweating or anything. But it looks like you're cool this morning sitting in there. So you really provide a great support and capability to the warfighter on the ground. And really what we'd like to do at this particular time is just ask you a question about your mission over there.
Yes, sir. Go ahead.
Go ahead. Give us a little feel for what you're doing today.
All right, so what we're doing out here is we support Task Force Spartan, and we are helping to work with our coalition partners in the area, as well as supporting them with developing their own space capabilities.
Well, Major Wilkins, are there organizations ARST can support, and can they be tailored to support unique or non-standard organizations?
Definitely, sir. So the ARST have an enduring mission to support CENTCOM as an ARST minus, or an Army Space Support Team, support coordinating element, where the top 2 or 3 leaders in the team integrate directly with the Air Force and supporting their strategic air and space mission set. Additionally, ARST have supported a NATO headquarters in support of major joint operations with NATO LANDCOM and its subordinate response defense forces in annual exercises.
Well, thank you, Major Wilkins. Thanks for what you're doing for our nation every day over there, and we hope you have a safe deployment and a safe return home. Thank you. Sensors and missile defense are critically linked through space assets and technology. Let's take a moment to hear from the 100th Missile Defense Brigade.
Hello, I'm Lieutenant Colonel Richard Mikowski with the 100th Missile Defense Brigade. I am a crew director with the brigade, and I am located in Colorado Springs, Colorado. The 100th Missile Defense Brigade is tasked with destroying intercontinental ballistic missiles in mid-course to defend the United States and designated areas. We are the U.S. military's only missile defense brigade and the only unit tasked with defending the United States against ICBM attacks in the mid-course phase of flight. Additionally unique to our brigade is more than 80% of our soldiers are National Guardsmen. The 100th Missile Defense Brigade is headquartered in Colorado Springs, Colorado, with the 49th Missile Defense Battalion at Fort Greely, Alaska, a small detachment at Vandenberg Air Force Base, which is located in California, and a security detachment at Fort Drum, New York. The crews that execute the ground-based mid-course defense mission are redundant, rotational, 5-soldier teams that operate simultaneously. One crew is located at Schriever Air Force Base, Colorado, and the second crew is at Fort Greely, Alaska. These 10 soldiers have the watch, control the system, and are prepared to engage a hostile missile at a moment's notice. The security forces at Fort Greely, Alaska also perform a round-the-clock mission securing the missile defense complex there. From the day the brigade activated in October 2003, the soldiers of the 100th Missile Defense Brigade have been the human element of the system and an essential part of the research, testing, development, and operations of the ground-based mid-course defense system. Using a sophisticated fire control system supported by sea, land, and space-based sensors, the soldiers of the brigade can track, intercept, and destroy the warhead of an incoming ICBM in its mid-course phase of flight. Continuous operation of this complex system and mission readiness is a credit to our soldiers' professionalism, intimate knowledge of the system, dedication to the mission, and continued partnerships. We are a small brigade, known as the 300 defending the 300 million, and we are proud to serve our no-fail mission every day.
This morning, we're joined by Lieutenant Colonel Richard Mikowski from Colorado Springs, Colorado. Richard, in your opinion, what qualities make a good GMD operator?
Sir, good morning. In my opinion, there are three qualities that make a good GMD operator. First and foremost, believe in the mission. There are those who question the validity of our program and mission. I, for one, have always believed in this mission and its success. Should there actually be a missile launch of the United States from a hostile nation, there is no doubt in my mind that the system would negate the threat. Second, trust in each other. Each operator has specific tasks, and only through a collective effort can a crew be successful. Crew members are prepared for long days and long nights. It's definitely physically and mentally draining. And third, training and readiness. In maintaining readiness, crews are subject to a rigorous evaluation schedule. Both scheduled and no-notice evaluations keep crews sharp and ready to perform our mission 24/7, 365.
Richard, thanks for that. Richard is a member of the Colorado Army National Guard. He's been working there for about 14 years, so I can tell you that the experience level that we have on these crews that perform this mission for this nation are very, very high in terms of capabilities. So thank you, Richard, for that. The 100th works closely with the Joint Functional Component Command for Integrated Missile Defense, which is also headquartered in Colorado.
Hello, I'm Colonel Dwayne Boyer, Deputy Commander for United States Strategic Command's Joint Functional Component Command for Integrated Missile Defense, otherwise known as JFCC-IMD and commonly referred to as JFIC-IMD. Now please listen and learn more of how the IMD team supports the warfighter on behalf of the United States Strategic Command.
Located with the Missile Defense Agency at Schriever Air Force Base, Colorado, this 150-person Joint Command includes military, civilian, and contractor personnel who serve as recognized subject matter experts across the missile defense enterprise. JFCC-IMD synchronizes missile defense planning, recommend allocation of missile defense forces, execute missile defense operations support, advocate for missile defense capabilities, and execute joint ballistic missile defense training and education. The United States faces an extremely dynamic global environment in which missile threats continue to proliferate and increase in complexity, range, and lethality. Missile defense is a global operation that requires synchronization across multiple combatant commands. To ensure planning efforts address the evolving threat environment, we apply a global perspective to support combatant commanders and the joint staff via assessments, force allocation recommendations, and inputs into both deliberate and crisis action planning. Our missile defense operations support includes a 24-hour operations center providing asset management, alternate execution capability, federated intelligence support, and missile defense network monitoring and protection. Our strong partnership with the combatant commands and services allows us to advocate for the warfighter's global missile defense requirements. This advocacy translates into recommendations for test requirements and operational acceptance of new capabilities and analysis and assessments of current and future capabilities. Lastly, we have developed a comprehensive program to close gaps between service, joint, and regional BMD training and education through our Joint Ballistic Missile Defense Training and Education Center.
As the nation confronts the uncertainties of an expanding and more capable global missile threat, JFCC-IMD's team of dedicated professionals continues to provide enterprise solutions to enhance the protection of our homeland, deployed forces, allies, and partners. Vigilant for the world!
Today, Colonel Tom Hancock, the J5, is joining us from, he's joining us from Omaha today, our higher headquarters. He and his team do a lot to further ally and partner integration and capability maturation. Colonel Hancock, what are the most prominent challenges the team faces in this endeavor, and which areas are you working for potential solutions?
Good morning, sir. As you know, effective integration faces a broad set of challenges that go beyond delivery of missile defense systems to our allies and partners. Burden sharing through interoperability or integration requires additional efforts across doctrine, organization, and training in particular. Our Nimble Titan campaign of experimentation brings together policymakers and military leadership to discuss strategic missile defense policies and operational procedures. Nimble Titan is considered to be the premier forum for open collaboration and exchange of views
And as of today, we have 25 nations and 4 international agencies routinely participating. We also provide training to our international students at our Joint Ballistic Missile Defense Training and Education Center and via mobile training teams. Over the past few years, we've provided training to the nations of Japan, Korea, and several of our NATO countries. Finally, JIFIC IMD is working to expand our ability to execute classified, combined defense design planning through an allied and partner modeling and simulation effort. This multilateral information sharing construct was created to enhance data sharing of systems and technical capabilities with a select group of allied and partner nations.
And we will actually finish our Nimble Titan campaign here in September. I think it's the 12th and 13th of September at NATO headquarters, which really is a culmination of a 2-year evolution in terms of bringing our allies and partners together in an environment where we can discuss critical missile defense issues. So Tom, thank you for that, and thank you for your leadership. And finally, you may or may not be aware, but we also have the Army's only astronaut detachment assigned to this command. Lieutenant Colonel Promotable Andrew Morgan and Lieutenant Colonel Ann McLean are our current active duty astronauts, and we're both currently training in Russia, preparing for the next space mission. We also have Major Frank Rubio, who continues his training as an Army astronaut candidate. Now I'd like to play a short video. We couldn't get them live today. They said they couldn't do the link from Russia. So we asked them if we could show this video. So please roll the tape.
You know, in the Army, we have an amazing opportunity to do a lot of different jobs in a short period of time. I've always been captivated by the magic of space, and there was just something inside of me that knew that's what I wanted to be.
The Army is great preparation to become an astronaut because Army astronauts are well known for their characteristics of leadership and being able to take a group of people and unify them under a common vision, all the while maintaining highly technical skills.
The intensity of training for NASA astronauts is an ongoing process. You have to get trained in neutral buoyancy lab, which is where we learn how to do spacewalks. We learn how to do robotics, to operate the robotic arm. We do International Space Station systems. And the last thing we do is T-38 flight training.
I'm a product of a complete Army education. And so if I was an attractive candidate to NASA, I owe that to the Army for the training that they gave me.
Throughout history, human beings have always had a propensity to explore. And now we're flying spacecraft in orbit, understanding that that's just not a fantasy land. That's real.
I think that's a hua. Hua. Well, hopefully today, over the last few minutes, you got a better appreciation for, one, the geographic dispersity of SMDC, ARSTRAT, JFCC, IMD, and the critical capabilities that we bring to not only the Army, but the joint warfighter. And so today, over the course of those few minutes, I wanted you to actually get to see the soldiers, sailor, airmen, Marines, and our allied partners that help us in that mission every day around the world. So with that, I would just end with saying that very difficult, if you've ever done one of these, very difficult to pull this all together. We had a combination of videos, we had a combination, as you could see, with the live feed, and they all worked fabulously. And that was not a result of me. I was kind of like General Hyten. I asked them what to do, tell them what to do, and they did it. So the people that pulled that together today is they're along the back wall back there, Mr. Joyner, Lieutenant Colonel Promotable Sue Smeltzer, Staff Sergeant Topper, Staff Sergeant Ramsey, and Staff Sergeant Scalabaka. And they were the ones over the last few months, plus others, that have pulled this together. So if you would, please give them a round of applause. So thank you for your time.